So far, we have worked with the only threads that are not returning any value. Let's work with the threads that will return some value, and we are going to use that. So for that, we are using a callable. So what we do here is, before using a callable, so what we do here is we are creating an executor service. We have talked about that in the previous episode, and we are creating a thread pool. So basically what it does is it gives us a thread pool with the two threads, right? Doesn't matter how many tasks we will submit to this executor service, it will use only two threads. The next one is that we are creating a callable. It's similar to runnable, but with one difference is that it returns some result. So we are creating a callable, and we are putting that thread to sleep for 1 second, and after that we are returning the value of the 42. The next one is that here what we do is we are to our executor service, we are submitting our tasks. So basically this starts our thread. So this starts our thread, and in the next line, right? So in the next line what we do, we are just printing that doing other works. This call here, it's asynchronous. So what it means is that whatever the work, whatever the logic we put here, right? This can work, this logic can work as asynchronously, non-blocking of the rest of the code. So for example, in this case, let's say that we have here we are just printing, but let's say we have here much heavier logic here, right? So in that case, again, this logic will go on in parallel with the whatever logic we put in this thread, right? So it's asynchronous. So it's asynchronous, but what we do, it's asynchronous, or you can call it non-blocking code. So what we do in the next operation here is we are from the future, we are waiting for the result, right? So we are waiting for the result. At this point, it becomes blocking, because at this point it waits our thread, right? Our thread, they are no longer asynchronous. It waits until the callable, until this thread finishes its work, and only after that it proceeds. After that, we are just printing a result, whatever the result we are getting here, and shutting down the executor in order to not waste the resources. Let's run it. Let's see that it works. So as you can see here, we are doing some work while this thread is running, so we can put some other logic here. It's a non-blocking, it's a asynchronous call, and then after that we are printing the results. Can we do better than that? Can we do better than we have here to improve this logic here for blocking the code? Yes, we can do that, and for that we are using the completion service. Again, we are creating a thread. We are creating executor service with the thread pool with the only 3 threads, and we are passing the executor to our newly created completion service, and more specifically executor completion service. We are passing our executor. So what we do here, right? What we do is we are in our for loop, so we are creating 5 tasks, and we are submitting each task. So we are submitting each task to our completion service. So we are submitting each task, and in the next one, right, we need to print all of those. In the next one, instead of using the get, we are using from the service, from our executor completion service, take. So what it does is it takes it doesn't wait, it doesn't block, but it takes the whatever, let's say we have submitted here 5 tasks, right? Whatever task is complete, it doesn't matter in which order we have submitted them. So we may submit let's say 20th task, right? 20th task is completed first, so we are taking that from we are taking that task from the pool, and we are printing that result. So let's run it and see that it exactly works as expected. As you can see here, it prints that in order of result 1, 2, 3, 4, 5, but it can print also in different order. It can print like result 3, result 2, and so on, because here it's a relatively non-blocking code, right? Relatively non-blocking code, because here we are not taking we are not waiting for the specific task to complete. We are waiting here to any task to complete, and we are taking from the executor completion service that task, and we are printing that. And again, we are at the end, we are shutting down our executor service. But it's better than the previous one. It's better than the get, because here it completely blocks. It waits until it finishes. But here we are waiting until any task finishes. It's still better than this one, but can we do even better than that? Can we improve? Yes, we can. And for that, we are using executor completion service. We are using here the poll operation, right? In the executor completion service, instead of the take, we are using a poll operation. So again, here what we do is we are creating an executor service, and in the we are we are also creating executor completion service. We are passing our executor, and then what we do is we are simulating a web crawling for the 5 websites, right? Let's say that we have 5 websites. Site 1, Site 2, Site 3, Site 4, Site 5, and we are crawling some information from them. So what we do is we are creating each task to our service, to our executor service. So we are submitting each task, and we are simulating the network delay here. So we are taking some random number and adding 500, and we are putting the thread to sleep for that amount, right? So for that amount, and after that, we are returning a value that fetch data from the URL, from the certain URL with after certain delay, right? So that's the task that we are submitting to our service. So the task we are submitting to our service, and at this point, right, we are going to submit all the tasks. At this point, we are submitting all the tasks, and each task creating a separate thread, and in the not separate thread, but we are using only in this case 5 threads. Yeah, in our case, for our specific case, it will be 5 threads it will create. But let's say that we have 10 threads. Then in that case, we have only 5 threads. 5 of them will be executed as soon as those 5 threads finished its work, right? But in this specific case, we are creating 5 threads, and each of them in parallel fetches the information from that URL. So at this point, we have submitted all of them. Now this part is the most interesting, right? This part is the non-blocking. So what we do here, we are creating one variable received, and we are creating a while loop, and we are exiting this while loop only after received is equals to 5, right, to URL size. So what we do is, instead of calling the take as we do here, because this is blocking, because if let's say that none of the tasks are completed, in that case it will still wait until at least one task is completed, right? So it's still blocking, but it's better than the callable future. So here what we do is we are calling poll. Poll just checks that if there is any task that is completed. So it's a non-blocking, right? It's absolutely non-blocking. If it's not null, then we are getting from the future that whatever is completed, and we are printing that, and we are incrementing the received. If it's not, then in this case we can go and do some additional work, right? So we can print no task ready yet, doing other work, right? So we can add here whatever logic we want. Again, it's to make it non-blocking. So and here we are just simulating some work. We are putting that to sleep to 200 milliseconds, and at the end we're just shutting down our executor, and the printing all tasks are completed. Let's run it. This one is completely non-blocking, completely asynchronous service. And as you can see here, right? So no task ready yet. So we have submitted all the works. So at this point, we don't have any task that is ready that we can process. So we can do some other work. So let's say that in our program, we may have some other things, we can optimize our logic in order to do some other works. And as soon as it's ready, so let's say site 5 is ready, right? So we are fetching that, and we are printing that. Again, we are waiting for the next one to be ready, and again we are printing that, and we are doing that until all our tasks are completed. After all our tasks are completed, we are then after that finalizing our main thread.